State the video goal. Explain the basic principles of turbine engines, the different types, how their power is conceptually applied in devices such as jetpacks, and the safety, legal, and engineering considerations involved. Make clear this is an educational overview, not a build guide. Give a high-level description of the engine idea: air intake, compression, combustion, expansion through turbine stages, and exhaust creating power or thrust. Explain the difference between producing shaft power and producing thrust. Briefly describe common types without technical build details. Turbojet, mainly thrust turbofan, thrust with bypass for efficiency. Turboshaft, delivers shaft power for rotors or generators. Microturbine, small-scale gas turbine used for power generation. Not typical users: aircraft propulsion, helicopters, via turboshaft, power generation, and industrial drones. Explain at a high level how turbine output is converted for different uses to produce direct thrust for high-speed propulsion. Provide rotational shaft power that can drive fans, rotors, or generators to produce electrical power for hybrid systems. Use conceptual examples: a turboshaft powering a rotor system versus a turbine producing direct jet thrust for short bursts. Describe the idea of a personal flight system conceptually. Thrust versus control trade-offs, weight and balance importance, need for reliable control systems, fuel and energy constraints, and the challenge of safe human carriage. Emphasize that certified prototypes are developed by teams of engineers with testing, infrastructure, and certification, not as DIY projects. Outline key engineering domains involved without construction steps: propulsion system selection and integration, power transmission or exhaust management, flight controls and stabilization systems, fuel system design and safety management, thermal management and shielding, avionics and pilot interface, structural design and human safety systems, harness, emergency cutoffs. Stress the critical importance of safety and regulation certification and airworthiness standards for aircraft and personal flight devices, ground testing, instrumentation, and controlled flight testing in licensed facilities, emergency procedures, redundancies, and maintenance regimes, legal restrictions on experimental flight in most jurisdictions. Discuss broad trade-offs: thrust to weight versus fuel consumption, range and endurance limitations, noise and environmental impact, reliability versus complexity, cost and manufacturability for commercial use. Present safer ways to explore the technology. Study turboshaft and electric propulsion concepts using simulations and approved educational kits. Examine commercially developed personal flight systems and research projects for inspiration. Consider hybrid electric concepts where turbine engines drive generators rather than direct thrust. Recommend safe next steps: aeronautical engineering courses and textbooks on gas turbines and propulsion simulation tools, and academic CFD resources for conceptual study, industry papers, university research groups, and reputable manufacturer white papers. Attending workshops or working with licensed labs and professional engineers. Mention as inspiration that companies and research teams explore personal flight and turbine applications. Encourage viewers to study certified products and public demonstrations rather than attempting builds themselves. Summarize: turbine engines convert air and fuel into power or thrust. Their integration into personal flight devices involves many engineering domains, and strict safety and legal requirements reinforce the message: do not attempt to build these devices at home. Encourage learning through formal education, simulation, and collaboration with certified professionals. Show labeled, animated diagrams of airflow through a turbine: intake, compressor, combustor, turbine, exhaust without construction details. Show conceptual illustrations comparing thrust versus shaft power. Show footage or images of certified aircraft engines and industrial turbines, research lab demonstrations, university labs, and company concept art of personal flight systems. Show overlays listing safety and regulation reminders. End with call to action: study, simulate, and work with professionals.